Hello. Right, are we ready to do this? Are we ready to do this? Do what? Finish off the integration chapter. Yes, at last. We get to the final bit, okay? So it's been emotional, hasn't it? So we got all that integration by inspection stuff, and we had substitution going on, we had by parts, we had partial fractions again, we had trapezium rule, finding areas under curves was in there somewhere. Separation of variables, and now, this is the last bit. So huge chapter, and well done as well. Well done for sticking with it, okay? You can nearly think, yes, at last I'm at the end. But then after the chapter's finished, that's where the hard work comes. Sorry to say that, okay? But basically what I mean by that is each exercise has got its own theme, hasn't it? You're either always doing it by inspection, or you're always doing it by substitution, or it's always by parts. In an exam paper, you've just got a question, and you've got to figure out which bit of the integration chapter you've got to use. Okay, so the hard work is in trying to apply all you've learned into past papers. Okay, and that's why practicing past papers is really important. Okay, don't just think, right, done the chapter, that's it. Hey, I finished. My A-level course is done. Do the actual past papers as well. Okay, because if you can do past papers and get all the integration questions correct, which is pretty hard, then you can say you've understood it. Because that's what an exam is at the end of the day. An exam is a test, obviously, that makes sure that you fully understood the whole syllabus and you're able to apply the right technique to a particular question, okay? An exam is not, can you do this exercise? Bear in mind, this is the exercise where you always have to use substitution. Yeah, hopefully all that makes sense, okay? Anyway, back to this, okay? What I'm doing is I'm reading through the example there. So can you see that all right? Yeah, sure, good. That's example 27 on page 326, okay? I'm not copying out the whole question, all right, but I'll read it. It says, the rate of increase of a population P of microorganisms at time T in hours is given by this. dp dt is equal to 3p, and it says k is greater than 0. Why does it say k is greater than 0? Yeah, I'm not too sure about that either. Okay, should we just ignore that for the time being? And if that comes into the question later on, we'll deal with it. But let's read the question again. Rate of increase for population, blah blah blah. dp dt equals 3p. I'm not seeing it. I'm not seeing where k is. Okay, so okay, I've written it down, but I don't think it's going to feature in the actual answering the question, to be honest. So let's just put that down to a typo, shall we? Unless someone can tell me a reasonable answer as to why k is greater than 0, but I can't see one. Okay, so we'll ignore that. It says initially the population was of size 8. Okay, well that's kind of useful to know. Okay, that's useful to know. So when it says initially, with something like this, population increasing over time, initially means when t is equal to 0, p is equal to 8, I think it was. Yeah, okay. That's what it means, okay? Initially, when t equals 0, population was of size 8. That is more useful. That's going to be helpful. Part A, find a model for p in the form p equals a e to the 3t, stating the value of a. Okay. Find a model in the form p equals a e to the 3t. Another way of asking the question is to solve this differential equation. Okay, and you need to know that that's what the question is asking you to do. When it says find what p equals, there's no derivative term in there. This is a first order differential equation, dp dt equals something. We need to solve that differential equation by getting p equals, okay? And the way to do it is separation of variables, okay? So that's what we're going to do. So if you didn't know that, you see, in the exam, you're getting nothing for the whole question, I'm afraid. Nothing. Okay, because you need to use that to be able to answer that. Can you imagine that? A whole question may be worth 10 marks more, 15 marks. You get nothing just because you didn't know how to separate the variables. And that happens sometimes. Okay. So let's just do this. So we're going to put the p onto the left-hand side. So you get 1 over p. Tp is equal to, as I'm sure I've mentioned before, any numerical values, just keep where they are. There's no sense of putting that over there. For goodness sake, you just don't have a third anyway. Keep it as 3. Okay, so I'm hoping you're happy with that. integral of 1 over p dp equals integral 3 dt. And we'll integrate that and see what happens. This is a lovely easy one, isn't it? Natural log of p, and you're probably thinking, why can't all integrals be like this? Because they can't, that's why. 3t, and then what do you want to do for the constant? Okay, to be honest, it doesn't make much difference, okay? Because we're going to work out what that is now, okay, using this, okay? It says that t equals 0 and p is equal to 8, okay? We can work out what it is quite easily, okay? So, you can either do it now or later, okay, but I'm going to do it now, okay? So put in p equals 8, you get natural log of 8 is equal to 3 times 0, which is there. See, done, simple as that, okay? So what that means is natural log of p is equal to 3t plus natural log 8. Okay. Reading the question, it says it needs to be in the form p equals something. Okay. So what do? We do p is equal to, remember, we're doing the inverse of natural log to both sides. So that means you're raising this here, aren't you? You're doing e to the power of this. So that's going to be p is equal to e to the 3t plus natural log 8. Okay? Then read the question again. That's not quite in the form, is it, that it wants it, okay? And even if it wasn't how it wanted it, you'd want to simplify it anyway, okay? So how can we simplify that? So that is the same as, I'm doing 2 steps for you, e to the 3t multiplied by e to the natural log 8. Yeah? Okay. I'm sure I didn't need to remind you of that because you've solved exponential equations many times already, haven't you? And so can you write that as this? As in, would you be comfortable writing like this? I jolly well hope so, because I've just done it. Okay, remember that is just equal to 8. And I'm just going to check the question again to make sure it's in that form. P equals a e to the 3t. Yeah, that's fine. Stating the value of a. So let's just be careful to make sure we do that. Because if a question specifically says state the value of a, let's not leave that bit out. So we're a equals 8. Okay, and that's that. And that's that. That's part A done. Okay with that? Good. Well, because that's the integration bit done, you probably don't have to do any more integration for the rest of the question. I mean, there are some questions where you might have to, but you probably don't for the rest of this question, okay? So what I'm going to do is, before I go ahead and answer the rest of the question, I'm just going to rewrite this a little bit better, okay? So I don't need that because I've used that already, and this here I've already solved the question, so it's like I'm just turning over the page really, and I'm just going to answer the rest of the question. The only thing I need really is that bit there, isn't it? That's the only thing I need to write down. So I've got the population is equal to 8e to the 3t, where t is in terms of time. I can't remember what units for time it was, probably years, could be days, could be months, but there we go. Let's just check that. Oh gosh, I was wrong on all counts, hours. But that's just a warning to you, always check, okay, because it's not really clear what the value of t stands for in terms of time, okay. Right, B finds the nearest 100, the size of the population at t equals 2. Oh, that's easy. Okay, t equals 2. Find the size of the population. P is equal to 8 e to the 6. Yeah. I need a calculator now, of course. So e to the power of 6. Yeah. Times by 8 equals. Right. So I got 3,227 point something. Just as a word of warning, if the question doesn't say round it, then you'd always give it to the nearest integer. So it would be 3,227, okay? But it does say nearest 100, doesn't it? So 3,200, yeah, 3,200. Just want to check that, yeah, size of population to nearest 100, okay? So there it is, that's that. And then part C. Find the time at which the population will be 1,000 times its starting value. Find the time at which the population will be 1,000 times its starting value. Starting value is 8, wasn't it? Remember? So what we're saying is find the time when p is equal to 8,000. Okay. So what we want to do is solve 8 e to the 3t is equal to 8,000. Yeah. So e to the 3t is equal to 1000. Could these questions be any easier? Sorry if you're finding it hard. You know, yeah, all things are relative, but this is a pretty easy question, okay? Even the integration bit is pretty easy. I mean, come on, they introduced the separation of variables. You know, those were harder questions because there's some trigonometry involved in it. These are just, I'm hoping you're finding this a pretty simple question, okay? Yeah, good. Yeah, smile for me, okay, reassures me. So 3t is equal to natural log 1000, and t is equal to 1/3 of that, isn't it? 1/3 natural log 1000. So let's just work out what that is. So natural log 1000 divided by 3 equals, well, I've got 2.30 dot dot dot. Yeah. Okay, so camera stopped recording again. It's because all these lessons I'm doing, it's taking up all my camera space, and unless I delete it permanently, it kind of doesn't give me a signal. The camera doesn't even say woo about stop recording, it just sort of stops. Anyway, thankfully, it only stopped almost towards the end, right at the end. It only missed off the last minute or so, okay? So I'm just going to pick it up from where I left off, okay? So I've just written out the 2.30, okay? And then what I usually do there is just check the wording of the question, see how exactly it wants me to answer this question, okay? So sometimes when it says it's in T hours, it says T hours after midday or something like that. If it gives a timing reference, it's normally a good idea to write down precisely what time this answer would be. So if it was T hours after midday, I'd be looking at 2 o'clock in the afternoon or something like that. I'd write down that as natural time. But because there is no timing reference, it's okay to leave your answer as a number of hours or a number of hours and minutes. I'm going to do both, okay, to cover myself. In the exam, I suggest you do the same, okay? So I've written the 2.30 dot dot dot, so I'm going to write that in terms of hours, okay? Now, bear with me, because I did stop the thing, okay, I've deleted that from my calculator. So I'm just going to get it up again. Natural log of 1000 divided by 3. There's that. Okay, so I've got the 2.30 dot 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 there, okay. Subtract 2, multiply by 60, so 18 minutes, okay. So that's 2 hours and 18 minutes. That's fine, okay. That's the only thing to watch out for, okay. If you did have to give a time in the afternoon, it would be 2:18 p.m. or whatever, okay. So I'm hoping you're happy with that, okay. Part D asks us to state one limitation of the model for large values of t. Can you see? Oh, I forgot to rub that off before I start recording again. Well, can you see what I'm getting to think about? When it says large values of t, it's a bit of a giveaway really. It always means what happens when t tends towards infinity for large values of t. Well, the population obviously also tends towards infinity, and you know, that's your exponential graph, isn't it? Okay, it does this, okay? And that can't happen, okay? That cannot happen, okay? You cannot have a microorganism or population for that matter increasing infinitely over time because there's only a finite amount of space, okay? It doesn't matter whether we're talking about humans on the planet or we're talking about microorganisms in a room or laboratory or whatever. You've got a finite amount of space, and so you can't have something increasing infinitely, okay? So that's the reason that I would give. Happy with that? Good. All right. Well, I'm hoping that's okay with you. Again, sorry for the break in the video, okay? I promise I'll delete permanently all the things that I'm uploading to my computer, okay? So I can just delete everything permanently from my recording device, okay? Anyway, I'll go to the next example. Let's hope the next example is a lot more challenging than this, because this was really, really simple. Really simple. I'm hoping you're, yeah, good. I'm glad you found it simple as well, okay? No one's crying, are they? If they are, sorry. Cheer up, it's integration. Go on, you've got to smile at integration. Go on. Anyway, let's do the next example, okay? Oh, I hope no one is crying. You don't know whether I'm joking or serious or not, do you? But I'm serious when I say that was a really easy example. Okay. Anyway, enough. Let's stop the video and yeah, good. Still recording.